As far as I understand, nerd is a person who's really deep and passionate about a technical subject, potentially to the exclusion of things like friendships or relationships. A geek is somebody who has outwardly revolting, I don't know better words for this, but out like they're an actual societal outcast. So a geek is like the person who stereotypically smells bad, has facial acne, that type of stuff.
I remember it was worse.
Yeah, geek is kind of a slang term for a person you don't want to hang out with, but a nerd is a person who just doesn't understand that people around them have feelings.
So you're a nerd.
I'm a nerd. My producers have given me an intro page to read for you all. First of all, I'm Craig Bergman. This is Alex Fortin, coming at you live from the Cold Bore studio. Welcome back to Nerdin Out with Cold Bore. Today we're diving deep into the world of data delivery for completions operations. Now we know this might not be everyone's idea of a good time, but if you get excited about data protocols, real-time streaming, and data security, you're in the right place. So grab your favorite data snack, put on your nerd glasses, and let's nerd out together. Because today we're speaking directly to the data nerds, the spreadsheet ninjas, and the protocol pros. Let's break down how we're turning data delivery into a fine art over here at Cold Bore Technology.
Fine art.
Oh.
Not science.
No, it's an art.
It is kind of an art.
You know, over the last few days, the new Apple conference happened where they announced their new products. And of course, we're all Apple Watch enthusiasts. I like it to track how much I stand during the day. So I'm with bated breath. I'm looking at the new Apple Watch Ultra that came out, which was a new color. And they have a new strap for it, which is great. You know, if you don't like silver, then they have a new option for that. The kicker is I could just see people around the world tuning in to watch Apple's updates. But recently, we're talking to our clients, we're visiting them, and we're sharing our software development managers with some of our clients so we can see how the product's being used. And a couple of questions that came up was, can you do this? And ironically, that was a feature that we'd released several months ago. We have really good release notes, we have videos, we have documentation online. Like somehow Apple has managed to take all of their clients in and bring them into this live press release. We've released a pencil and everyone's clapping. Yet our stuff is, you know, fundamental. Access your new data in exactly the way that you want, but we can't manage to bring eyes to our press releases. What are your thoughts on that?
So I'm witnessing the hot potato here.
Boom!
Yeah, I mean, it is challenging. Like, I mean, Apple is such a brand, and you know, they're really good at that branding piece for sure. And the reality is, like, our customers are also, you know, regular consumers, and you get bombarded by 1 million, you know, product update. Like, I don't know. I'm looking at especially my wife's feed. Like when I look at her emails, like, I don't know how she managed that. She probably gets 300 emails a day from, you know, the promotion from this thing and, like, you know, software release, and we changed our terms of conditions. And
it's even better when you click in and it's like, look at this new feature. I'm like, stop telling me these things.
Yeah, exactly. Because that's the way that I operate, actually. Like, if I was like, I'm probably like the guiltiest person about this here, because every time I get a new email in my inbox from even a company that I actually like, even if it's Apple, honestly,
yep,
I'm like, unsubscribe. Right? I'm trying to, like, just limit the amount of, like, I'll, you know, and maybe that's this is the way that I operate. It's more of like, when I need it, I'll seek it out.
Yeah, I'll ask you the question. Thank you very much.
And I think that's where, like, that human presence, right? When we say, like, we literally, like, put one of our lead software eng on a plane to Houston to go sit with a big group of our customers and just, like, be there. And, you know, and that's kind of where these things tend to come up, right?
That's right.
And I think that's just it's just human. I think it's just something that we need to be very cognizant of and keep doing.
Just part of the cost of doing business, I guess.
Yeah. All right. So the topic today, like Craig mentioned, data protocol. So we'll talk about everything that we do. Like, it's pretty broad because at Cold Bore we do a lot of different data delivery mechanics, and I'll get into that right now. So we'll talk about so the raw data protocols and how we and how we deliver the data to our customers and our partners. Talk about the layers of enrichment and contextualization pieces that we throw on top of our data set, and talk about like the different data sets themselves that we transmit to our partners as well.
Yeah. So, Alex, can you kind of give me a heads up? Like, how can our customers look at our data?
There's actually a ton of ways to look at our data. The most common things in the past have been kind of request response models. Think about RESTful APIs. That's what we've been doing for the longest time. Request response models also include like things like good old CSV files. We still have plenty of operational people and even engineers that like to just dump that into a comma separated value. They have their own script that they run on top of that, and that's what they like to work with. And that's something that we provide to our customers today. Um, another method is streaming. So streaming really works well when you have use cases where you need data really fast. Our dashboard, for example, both on edge, on premise, and in the cloud, works with the streaming mechanics because we're always trying to feed the data as fast as possible to the eyeballs of our customers. So streaming, like we do mostly WebSockets. That's the protocol that we use on the web and on site. And on site, we also use quite a bit of MQTT. So for people in the industry and other industries, actually, it's kind of a telemetry protocol that's widely used in the type of application that runs on the different service companies that runs on prem. And so that's why we also support that because it's fairly well known for all the partners working out there. Um, Third, we have queuing, and so that's kind of a mix between request response and streaming in the sense that there's more persistence. So the issue with streaming is if you are a client and you're not reading from the stream at any given time, that's gone. Queuing kind of solves that in a way that you get a buffer of data over time, so that even your client dies or anything like that, like you can always make sure that if you're trying to grab every single data point that is coming for let's say a frag channel or whatever it is, that you're always going to have insurance that you got every single data point through the queuing system. Fourth, we have data warehouses, and those stats came pretty prevalent in the last few years. When we talk data warehouses, we talk about Snowflake, which is the famous one, and Databricks is one that we've seen out there quite a bit, and which are basically glorified databases that are really easy to synchronize together. And that's a way that our customers have been wanting to consume the data recently, is through those services. So we do expose the data through that. And finally, there's your good old eyeballs. Most of our operational folks, that's their first go-to. So either through our web application or our mobile application.
Yeah, a couple things that I think interesting. One, when I was looking up the right spelling of the word queuing, I got this fantastic MIT article about the popularization of the word queuing and when it actually rose and fell in popularity. Apparently, in the 90s, QUEUEING became the least popular spelling of queuing,
Okay.
which is truly a nerd thing.
Yeah. It's before I spoke English.
Yeah. The I don't know, trying to make it more podcasty.
Oh yeah. Don't keep going.
This is good. This is really podcasty. So would you consider eyeballs a separate method of data access, or would you group that in with data streaming?
I mean, they're different because the way that the way that human process the data is very different than the way machine process the data, right? So like, streaming, I can stream 16,000 data points at the same time to a system, right? And just create any sort of visualization for it. Like it can kind of see the data like immediately, right?
Yeah,
Your
like those speed readers. Just
if I'm sending like let's say I had a terminal screen with 16 different little views that were changing in real time every second, it's really, really hard for a brain to process something like that, right? So that's where like the eyeballs are different, because that's what we work on our charting. We work on like how much data we can overlay and how we can create scales on each side of the screen, for example, right? So that your brain can kind of like conceptualize what's going on just at a brief look at the screen. And that's very, very different than in terms of delivering that data than um, just pure like I'm just streaming the data into a database.
Which is, I guess, a necessary evil, creating UIs for people to look at the stream data to get it into the databases.
Definitely, because at the end of the day, like as much as we're getting in a world where we want to offload some decision making over to machines, like the reality is that most of the decision making that we're seeing right now in our industry is still done by humans. And what we're trying to do is to enable them to make the best decision in the close to real time as possible through like that visualization layer.
So, what are some of the advantages of some of the queuing systems versus the live streaming methods?
Yeah, a bit like I mentioned before, like the streaming is always going to be faster because there's absolutely nothing stopping the data between the sensor and their end destination. So for stuff like using our live graphs in the cloud, for example, like that uses streaming, because the reality is from your eyes, for example, even like if one data point gets lost somewhere in the stream, since there's no guarantee on the streaming, it doesn't really matter, because like the amount of data that you're sending on your front end on your web browser, like you wouldn't even notice that one data point is missing, for example,
Yeah, you could probably
right?
drop half and you wouldn't even see it.
Exactly. And so so that for that type of application, streaming is really good because you're prioritizing speed over like completeness of every data set, of every data point that you're sending over, while the queuing like it's more like when you want to ensure that you have every single data point, right? So if like I'm transferring vast amount of data to a third party system, I want to make sure that there's nothing that gets left over, right? So the queuing system is really well done for that, because you ensure that every data point gets in the queue, and then like from the client consumer standpoint, like if you haven't consumed it, it is there.
Now, does queuing natively support things like data gating until the quality is matched to score, or
Oh,
I don't know?
it's
I'm
like a
just
trick question.
just throwing it out there.
Not natively, that's for sure. Right. So like, very, very coarse way to do um uh to do queuing is basically like the same as your data stream, but you're just sending it over into queue. But maybe Craig, you can get over like how are we thinking or uh of gating the data through queuing systems with our data quality slash data ops stack.
Yeah, absolutely. And this will definitely be covered in, of course, the next podcast. Don't forget to like and subscribe, Cold War Technology. I'm sure the producers will really appreciate a comment or something like that. Ask a question of something you're interested in. But our next podcast will all be about data governance, some methods that we're employing at Cold War. Back to your question, what we're doing is we're live scoring our data as it comes in and identifying anything that violates one of our data governance protocols, and we're using that to gate whether we pass that on to our clients who are expecting pristine, qualified data sets.
Yeah, so that's a very good like segue into what we are just talking about, where for streaming, like if I'm trying to make sure I get the best data as of right now, T0, like from what I know, I need the data in real time, as close to real time as possible, versus like we're going to put all that data into a long-term storage place, and we need to create some insurance about like uh I don't know where I'm going with this.
No, I totally understand. Like, basically, the thing is, what you're saying is if you're looking at an operations data set, is our pressure too high for the activity? I need to react on it right now. You need live stream, potentially not complete, potentially not quality controlled. You just need to know what the sensors are saying. On the other hand, if you want to know how much sand did we pump
That's
last
right.
year, we need to know exactly how much. Having an erroneous spike in some sensor failure, that needs to be filtered out. We need the right number.
And the reality is, like, if you want, the more constraint that you put on that, like at that gate on the data quality, the more compute time you need in order to verify that all your characteristics of your data match a certain thresholds. and that plays directly against your streaming side where you're trying to get data as fast as possible. So that's where like the queuing is really well built for stuff like we're doing for data ops, and allows us to queue the data up. And as we run through verifications on that data set, while the streaming side is meant to be like from sensor to eyeballs, how do we make sure that we can get that data over directly without any interruption?
Fantastic. Let's go into layer of enrichment. I like that.
Yeah, let's talk about that. I mean, that's a big part of what we do at Colbor, is that we enrich the data and we contextualize the data, right? So the challenge of completions is that you have all those different data sources on site, right? And they have their own kind of quirks. But the advantage that we have of being out there for an operator or a third party or a partner is that we can create kind of like, I call them the state of the pad at any given time. So we can infer from all the raw data that we get what's going on the pad. So, for those that have seen our application, we talk about our critical path and everything that's happening there. So we create the critical path from the raw data, which contextualizes what's going on in every second and every day on a job. And so when you look at it from the other side, when you want to actually go look at data, you actually do the opposite, right? So what we do is like we get all the raw data and then we create a contextualization layer on top of it that helps you kind of map your way through that data set. And then when you are going to look through that data after the fact or during or whatever, you actually come from the top, look at the context and say, what am I looking at, right? What am I looking for? I'm looking for, the treating pressure or the wellbore pressure on well X at this time during stage X, during the pad or the slurry or the start of the slurry. And then I can kind of ask that question, if you will, through any of the mechanics, right, that we have for data transfer to that contextualization layer. And that will map me to like that raw data feed essentially, or like the original sensor data that I'm actually going to give me the answers that I want.
That's right, because just looking at raw data, you don't really have the cues for the questions to ask against the data. You need a bit of context to identify what you're looking at.
Yeah, because like what you're looking at is plain comma separated data, right? Time stamped. That's what you're getting, right? If the valves were open on a certain well during that time, like what well were you actually fracking? Like if you look at a frac data set, you'll get a bunch of pressure. If you don't know at what point were you putting pressure on certain well bores, it's close to impossible to determine like what sort of treatment you were putting on each individual well.
That's
Right.
right.
And that's obviously something that everyone needs to do when you're trying to make sense and leverage the data on a completion site.
Just going back now, you mentioned a term, critical path. Can you describe what that is?
Yeah. So the critical path is our internal name for like essentially what we have in the application is a Gantt chart and each line of the Gantt chart is a well. And we're trying to capture the activities that are happening on each well at any given second of the day, right? So think about your critical path, typically really centered around frac. So what is getting in the way of your fracking, right? So on the critical path, you'll have standby times, right? You'll have your wirelining, your well switches, and your fracking, right?
Now, the interesting thing about critical path, that name actually came from 8-ish years ago. I was in a boardroom with our CEO at the time, and there was a gentleman with some very bright green glasses, and he kept asking, what's the longest tent pole? How do I see the longest tent pole? So we started asking him questions about this, and he said, I just want to know the critical path. What thing has to happen for us to get to the next stage of the operation? So that's where the name came from.
Yeah, and that's what a critical path typically is in any other context, right? It's like you're typically, it takes you from point A to point B, and what are the necessary steps for me to get from one to the other? Right?
Fantastic. So that's the layer of or that's part of the layer of contextualization against the data set.
Yes. So there's all sorts of different type of events that are happening on a frac site that are part of our state of the pad that don't necessarily are not represented on the critical path, but sort of exist in the background. I'll give you an example of that. So if you look at our critical path, like I said, you'll see waterline, pump down, and frac mostly one after the other. But then you can think about like places that are resource constraint. If you don't have enough water in your water storage tanks, you're not going to start that frac job, right? So there's some context that also comes from things that are not typically on the critical path like that are part of our event driven solution that will say, you can say, well, I need my water level to be above a certain threshold to start a frac, right, or a stage. So that comes in as a bunch of event messaging that we display on our dashboard and send over to different third parties through our either MQTT broker or websocket streaming.
So going back, we talked about data transmission and how we're sending data to our clients as well as to the eyeballs. Now, what protocols do we use to send the actual contextual data? Is that similar to how we're sending the CSV data?
So we do have an API, right? So like it kind of gets us into like the different types of data sets that we have, right? Because a lot of times, like when people talk about protocol data transmission, we talk about the raw data, like the sensor driven data. That's all the time series stuff. We do almost all the things that we talked about for time series stuff, like REST, CSV, WebSockets, MQTT, Kafka, data warehouses. For the event data, right, the state of the pad data, we do mostly we stream them, and we also have a REST API for it.
Got it.
But we're also looking at adding that to our queuing system in the near future.
Yeah, and that's one of those tricky things because in real time you may have context A, but as we start to understand what's happening, comments get added, etc., you need to queue up a revision.
Yeah, so and that's something that's a challenge with the current state of the oil field is that a lot of time you'll get updated information after the fact. And you have to have a whole set of mechanics in order for the end consumer to be able to use that and change whatever was sent during the real-time operations. Because sometimes, and maybe Craig, like you have a good example of that on top of mind, like of something that we see being changed after the fact that we need to update downstream.
Well, let's say we had an NPT time block, and NPT is if we're not fracking a non-productive time. Usually we just know we're NPT, our operators or the people who want to take notes on the NPT aren't doing it in real time. They're actually trying to solve the problem. So what happens is the problem exists, you have auto detected, we're not fracking, and then an hour later, a couple hours later, the OSR or the well site super or one of our data techs will go in and provide context around that. That wouldn't be available real time. It would be after the fact.
Yeah, so you get a plain just NPT block generated by our APR algorithm, but then until they get the context fitted in with someone that has to go through a drop down of like our categories or NPTs.
Yeah, waiting on weather, tornadoes coming through.
Yeah,
probably not doing that in real time.
Yeah, so that's when you need to be able to update that NPT block that you got maybe 12
yesterday.
hours ago.
That's right.
Now that it's been categorized by someone on site.
Makes perfect sense. I think I've got another meme queued up for today. All right, so this meme specifically, Alex, is there's a couple of people and they're challenged to guess a person's height. I love this because we're constantly being asked by operators, what can you do with this data? What operational decisions have been made based off of your data set to save someone else time, someone else money, to cut back the carbon emissions, something along these lines? Like, how did you help somebody else? And the reality is, until you know how a client wants to use their data, it's really hard to give a good answer. I saw this short clip and I thought immediately, what a neat use of data. So let's have a look.
So apparently there's these two guys on this app who can guess people's height. Bro, there is no way that they can guess mine.
Start things off, we used a logarithmic function to determine your distance from the door frame behind you. Assuming it's a standard 80-inch door, we can then deduce your height using simple trigonometry to be 5'9".
But door frame sizes can vary. So this time we wanted to take an extra step, which leads us to this heating panel on the wall behind you.
That type of heating panel was only manufactured in the late 1970s by an HVAC company named Trane. Using that information,
In addition to knowing you're based somewhere in Los Angeles,
we were able to deduce that you live somewhere within these 10 square city blocks.
and it doesn't take a genius to see that you have a south-facing balcony patio.
After a comprehensive search of those 10 city blocks looking for buildings that meet those criteria, we discovered that you live at 3029 Chandler Boulevard. Is that the guy?
Yeah, that's it.
From the video.
Yeah.
I particularly like this part because this is referring back to an external authoritative data set to validate the data that they've got.
Yeah, measuring tape's a good authoritative data set.
The thing that I love about this is there's several of these videos that you'll see, Instagram, whatever, and it's guess this guy's height, and people look up like shoe models and they say this shoe's exactly 8 inches, and looking at the perspective of the person that gives them down to a 32nd of an inch. That's perfect. If the question is how much frac sand did I pump? Well, how are you going to get that? Are you going to rely on a stick measurement, rely on a tally book with some half-written pieces of paper, or are you going to look for an exact sample a second data set? Here's where we started pumping. Here's where we finished pumping. Here's exactly the sand that we used. And this is how you can provide data for your $1 million decision today.
Yeah, and it speaks to a bit of the next podcast topics, which is the dimensions of data quality. And we can see in this one that they actually use a couple of those, right? So they talk the cohesion piece, right? Where they're looking at like the environment and versus that person and say like, you know, based off that, like we can determine that that person's height's about this. And same for the double checking with the
accuracy
the
check.
accuracy check with an authoritative data set, which would be the tape measurer in that case.
Yeah, while he's sleeping as they break into his
Yeah.
apartment. It's perfect. Well, that wraps up this episode of Nerdin Out with Cold Bore. Thank you so much for watching. Don't forget, like and subscribe. Connect with us on LinkedIn. Please feel free, post questions below in the comment section and let us know what your favorite part is, or if there's something else you'd like to know about the Cold Bore data set or other nerd topics that we can touch on. I'm Craig,
Alex,
and have a fantastic day.
Nerds, data in hand. We rock the bytes and we'll take a stand. Calculators flashing like a disco ball. Cold Bore tech, hey, we answer the call.